Do it. Okay, go ahead and write down number 1, and we'll look at some rate problems here. So like I said, unlike the last class's lesson where I said something can go this fast, how long will it take it to get so much done? This one I'm giving you 2 speeds, and from that we're going to put them together to get a total speed. So this is a little bit different. So you're going to have 3 fractions on these types of problems. Let's read it and see what it sounds like first. One hose can fill up a pool in 30 minutes. So there's one speed right there, 1 pool in 30 minutes. Okay? Another can fill a pool in 20 minutes. There's another speed. So they're giving you 2 different things that can do a job in different amount of times. Now, why would one fill up faster? Maybe because the hose is bigger and it pours more water out faster. Next, we have the final question, which is how long will it take them to fill the pool if you had them both filling it up at the same time? So we have the first hose, we have the second hose, and then we have the total time. So let's go ahead and write these things together. The speed of the first hose is what? That's the time. But what's the speed of the? 1 pool in 30 minutes. Yeah, 1 pool in 30 minutes. Okay, what's the next one? 1 pool in 20 minutes. And now what we're looking at is how long will it take them to fill 1 pool? And the question is how long, which means the bottom number is x. Okay? So that's basically your setup. Once you've got that, then you've got your equation. From there, it's just like what we've been doing. So you do speed 1 plus speed 2 equals final speed. All right? So here we go. We need to factor these and give them a common denominator. Yeah, so first of all, let's break these things apart. 30 breaks apart into 3 times 10, and 10 is 5 times 2. So if I break this apart, we have 3 times 5 times 2. And as for the 20, if we break that apart, it's 2 times 5, and the x doesn't need to be factored at all. So now we're going to go ahead and make a match. What does the first fraction need? It needs another 2 because the fraction in the middle has 2 2's, right? But it also needs a what? It needs an x like the one on the end, so we need to put an x there. All right, how about the next fraction?
3.
It needs a 3. Anything else? It also needs an x, right? And the last one needs all the numbers. It needs a 3, a 5, a 2, and a 2. So now all of them have the same denominator, so we're good to go ahead and drop the denominator off both sides of the equation, and we'll simplify what's left. We have 2x plus 3x equals 15 times 4 is 60. And then we just solve the equation. So it would take 12 minutes. So this one says John can do his homework in 1 hour and Joanne can do hers in 1.5 hours. If they work together, how long would it take them? In other words, if they split their homework up and kind of somebody did some did the other. So let's go ahead and see how this works. So we're going to follow the same format, guys. We have 2 different speeds being added together to get a total speed in this word problem. So we have speed 1 plus speed 2 equals total speed. All right, so here we go. John can do his homework in 1 hour. What's his speed? Remember, a speed has two numbers in it. The time goes on the bottom, 1 hour, right? And then 1 homework. You could put 60 if you want to do minutes instead. Sure, you could do that. So 1 homework, 1 hour. Notice you're putting time on the bottom here. Now the next one says Joanne can do her homework in 1.5 hours. So what's her speed? 1 homework in 1.5 hours. And if you're going with minutes, then that would be, you're right, 90 minutes, right? Equals the total, right? How long would it take them to do 1 homework assignment if they were working together? So we don't know how long that would take. So now, I've been telling you guys to factor the denominators to begin with. When we have a decimal, I'm just going to say, let's just not worry about that. There's ways we could fix it, but we could skip the factoring step with a decimal. So let's go ahead and see how this pans out. So right now I've got 1 over 1 plus 1 over 1.5 equals 1 over x. We're not going to factor because there's a decimal. So all we need to do is make the denominators match. So this one needs a 1.5 and an x. Okay. This one needs, you could do an x, and if you want, you can also do a 1. You don't have to do a 1 because it's not going to really change anything, but for aesthetic purposes, we'll put it there. And the last one needs a 1.5 and a 1. Okay. So now all the denominators are the same. We have 1.5x here, 1x here, equals 1.5. So 1.5 plus 1 is what? 2.5. Then you're going to go ahead and divide. Now if you got a calculator, it may not be too difficult. But if not, I'll show you how to deal with this. 1.5 over 2.5. First of all, just like with an equation, we can move the decimal over on both of them. So I can move the decimal over here and make it 15 if I do the same thing on the bottom and make that 25. So now I've got 15 over 25, and then I would just reduce it, which is 3/5. So 3/5 of an hour, which if you were using minutes, let me think about that for a second. 3/5 times 60 would be 12 times 3 is 36. That's right, 36 minutes. So here's some for you guys to do.
Shut up.
No, before that.
Okay, number 1, guys, you should have gotten x equals 23rds, or you might have just changed it to a decimal, but I want you guys to know on your test it's going to be like that. For the next one, we would have number 2, you should be getting 60 over 13, which is about 18.46 for the first question.